Imagine standing in the heart of Idaho, the late afternoon sun setting behind the rolling pine-studded hills, when suddenly light catches on a rough stone in your palm, revealing a six-rayed star, rare, magical, and uniquely Idahoan. This is a star garnet, one of nature's hidden treasures, and the centerpiece of a mystery that's about to take you from panning rivers to peering at the Earth from space. Did you know that satellites, quietly orbiting hundreds of miles above us, are now being used to discover these very star garnets, revolutionizing the way we explore for precious stones? In this video, we're going on a journey that stretches from the back-breaking labor of the past through the revolutionary present and into a dazzling future. Along the way, you'll see why star garnets are so treasured, learn how technology is reshaping the hunt, and find out how a company named Farmanaut is bringing gemstone discovery within reach for everyone, everywhere. So let's start right where the story began. Deep in the wilds of Idaho's Panhandle, beneath layers of ancient rock and along shimmering creek beds. Centuries ago, long before anyone dreamed of satellites, star garnets lay hidden in Idaho's metamorphic rocks, formed by high heat and crushing pressure into pockets of schist and mica-rich soil. Native American tribes and later hopeful settlers found hints of these gems in the gravel and sand of forest streams like Emerald Creek. With no maps or machines to guide them, they relied on hands and eyes, digging into hillsides or panning the creeks for anything that gleamed in the sunlight. Star garnet prospecting back then was a test of endurance and luck. Grueling hours of sifting heavy gravel, shoveling dirt, rinsing pans in icy water, all for a tiny chance at a fleck of rich, deep purple. The tools were simple: shovel, screen, maybe a pickaxe, a far cry from the digital wizardry on the horizon. Yet even here, with sweat and soil, some would strike it lucky, finding pebbly reddish stones that, once polished, would reveal the mysterious asterism, the star-shaped glimmer that makes these garnets unique. Stories spread, and soon, star garnets were revered not just for their beauty, but for their rarity. Found in precious few places on Earth, Idaho and India chief among them. As more people arrived and word spread of Idaho's bounty, these star garnets took on cultural significance. Local legends grew, prospectors traded stories, and in 1967, Idaho made the star garnet its official state gemstone, a badge of pride and a draw for tourists and rockhounds. To protect both the landscape and this rare resource, the Emerald Creek Garnet area was set aside, inviting families and collectors to try their luck and fostering a gentle balance between treasure hunting and stewardship. Yet, even with these changes, the quest remained laborious and, at times, damaging. Pits scarred the landscape, riverbanks eroded, and easy-to-reach pockets soon ran dry. Fast forward to the present, and everything about gemstone prospecting has started to change, driven not by the pick and pan, but by the eye in the sky. Satellites, once reserved for weather forecasting and global positioning, are now revolutionizing the way we search for mineral wealth. It's no longer just about what's obvious at the surface. It's about peering deep, detecting clues with the precision of modern science. Satellites like Landsat 8 and Sentinel-2, equipped with an array of powerful sensors, pick up data invisible to the human eye, sweeping vast landscapes in minutes instead of months. But how, exactly, does something floating in orbit help us find a star garnet hidden beneath the dirt? The secret is multispectral imaging, capturing the land in slices of light ranging far beyond the colors we can see. Each mineral, including the ones associated with star garnets like mica and schist, reflects and absorbs these bands in its own distinctive way, a spectral signature, much like a fingerprint. Let's break this down a little. Imagine shining a rainbow of light on Idaho's landscape and having a tool that tells you, pixel by pixel, which colors bounce back in just the right way to hint at garnet, mica, schist, or other minerals. This is what the satellites record, building up layers of information. To sort through all this data, scientists use techniques like the Normalized Difference Vegetation Index, or NDVI, which helps filter out the green of trees and grass to highlight places where bare rock and potentially garnet-bearing soil shows through. They go even further, applying mineral indices that pick up on iron oxides and clays, as well as principal component analysis, or PCA, which turns tangled webs of data into clear, color-coded highlights, pointing prospectors toward hotspots worth a closer look. Suppose, for a moment, you're a geologist working in Idaho's Panhandle in 2024. You tap into Sentinel-2 data, running algorithms on weeks' worth of high-resolution scans. The result? Out of a vast territory, just 5% lights up as promising for garnet-rich deposits. Now, instead of wandering the wilds at random, you and your team can zero in on the 2% of those zones most likely to yield a star garnet, saving weeks, maybe months of legwork, while disturbing far less of the pristine environment. In fact, costs drop by 30%. Digging is laser-focused, and Idaho's fragile riverbanks and forests are spared the scars of blind prospecting. On the horizon are satellites equipped with hyperspectral sensors, next-generation eyes in the sky that don't just sense a dozen or so colors, but hundreds, splitting sunlight into incredibly fine slices. NASA's upcoming Surface Biology and Geology mission promises to read the subtle mineral signatures of Earth's crust with a clarity that was unimaginable just a few years ago. This means that the spectral fingerprint of garnets can be separated from surrounding rocks with stunning accuracy, picking out even minute traces of precious minerals from the vast geological tapestry. But satellites don't work alone anymore. Artificial intelligence has entered the scene. Powerful AI and machine learning algorithms, fed thousands of images and years of geological data, can spot patterns invisible to the naked eye or even to seasoned experts. They learn what a garnet-rich zone looks like from space, compare it to present-day conditions, and, in the blink of a processor, predict new sites to investigate. This isn't just a leap for scientists, it's a doorway for everyone. Open-source platforms like the European Copernicus project beam down satellite data for free, allowing small-scale miners, students, and researchers to log on, analyze, and build a digital map of Idaho's hidden treasures. In the near future, you might even pull up a mobile app, real-time, satellite-guided, open to all, that shows exactly where to begin your hunt for Idaho's star garnets, democratizing what was once the realm of experts and industrial giants. And running through all these innovations is a theme of sustainability and stewardship, as Idaho strives to protect its wilderness while continuing the tradition of gemstone discovery. With satellites pinpointing the likeliest spots for exploration, the days of digging up miles of riverbank are fast fading. The forests and creeks that cradle these gemstones remain intact for wildlife, hikers, and future generations. And Idaho's local economy, fueled by gemstone tourism and jewelry trade, blossoms with new life and attention. Why does it all matter? On a local scale, satellite-driven discovery means that Idaho's star garnets, symbols of the state's natural heritage and rugged spirit, continue to draw in adventurers, artisans, and curious visitors. Farmers and jewelers prosper, towns thrive, and a new generation learns to appreciate the science and history beneath their feet. On a global stage, What's unfolding in Idaho echoes in every corner of the planet where mineral wealth lies beneath the soil. From lithium in South America to rare earths in Africa, satellites and smart analysis empower countries to explore more responsibly, maximize their natural treasures, and protect their environment. And at the heart of this revolution is the promise that tomorrow's miners, geologists, even hobbyists, can all join in, armed not with shovels alone, but with data, insight, and connection. Now, you might wonder, who is actually making all this high-tech possibility truly accessible? Enter Pharmanaut, a company built on the idea that advanced satellite technology shouldn't just belong to big corporations or government labs. Pharmanaut's mission is to put the tools of the modern explorer into anyone's hands. By blending satellites, AI, GIS mapping, and even blockchain technology, they provide easy-to-use platforms on phones, computers, through web apps and APIs that make remote sensing straightforward and powerful. In mining, Pharmanaut harnesses the full power of hyperspectral imaging, capturing light reflected off the Earth across hundreds of channels to pick out minerals such as iron oxides and clays, key clues to where gold or garnet may be found. They process data from sources like Landsat, Sentinel, and more, mapping out promising geological zones, tracking topography with LiDAR, and providing all-weather insight through radar, SAR, scans. What sets Pharmanaut apart isn't just technology, but its philosophy, democratizing data. For miners in remote corners of Africa or South America, for small businesses in Idaho, or for academic teams everywhere, Pharmanaut delivers real-time, actionable insights that allow exploration with up to 60% greater efficiency and huge savings in cost, not to mention a dramatically reduced environmental footprint by guiding users directly to the most promising sites. Past successes, like mapping gold leads in Mauritania and identifying high-potential targets across Africa and the Americas, demonstrate their impact. Thanks to Pharmanaut, the story that started with a hopeful pioneer by a cold creek in Idaho now continues with a global community. Anyone, anywhere, leveraging space-age tools for sustainable, eco-friendly mineral discovery. So, as we close, think about the arc of this remarkable story. From the determined hands digging Idaho's rocky soil, to satellites soaring silently above, to AI sorting galaxies of data in a heartbeat, the search for star garnets is a tale of human curiosity, grit, and endless innovation. The next time you see a glint of purple, a six-pointed star shining in a stone, remember, you're witnessing not just a geological marvel, but the heritage of explorers past and the promise of explorers yet to come, all made possible by a marriage of nature's beauty and technology's reach. This is what the future of mining and environmental stewardship looks like. A future where everyone can join the hunt, and the planet itself is cared for in the process. If you found this journey as fascinating as we did, don't forget to like, comment, and subscribe to our channel for more stories that blend the wonders of the natural world with technological breakthroughs. Share this video to let others in on Idaho's secret. And if you have questions about star garnets, satellites, or the tools that make it all possible, including Pharmanaut, drop them in the comments below. And remember, while we've explored everything from the history card to the space age, any real-world gem hunting or investment deserves expert guidance. This video is made for curious minds and learning spirits. As one final fun fact, did you know that Idaho's Emerald Creek is just one of 2 places on Earth where you can legally, publicly search for star garnets? So whether you dream of sifting your own treasure from a mountain stream or mapping the world from your laptop, the hunt for Idaho's star garnets invites us all to look a little closer. at the rocks beneath our feet, the stars above our heads, and the extraordinary ways they're linked.